Attention all Earthlings! Are you curious about how solar flares and space weather affect our planet? Buckle up and get ready for an electrifying ride as we dive into the fascinating world of space weather and discover its impact on our daily lives. Don't miss out on the chance to uncover the secrets of the universe. What is space weather? Activity on the sun's surface creates a type of weather called space weather. The sun is far away, about 93 million miles, 150 million kilometers, from Earth. However, space weather can affect Earth and the rest of the solar system. Space weather begins with the sun. The sun gives off electromagnetic energy in many wavelengths, including visible light, radio waves, ultraviolet, high-energy X-rays, and more. The sun also emits a stream of radiation in the form of charged particles, plasma, that make up the solar wind. Occasional energy bursts resulting from huge explosions on the sun send plasma and radiation hurtling through our solar system, sometimes in the direction of Earth. Solar flares, coronal mass ejections, CMAs, and solar prominence events are examples of solar phenomena that can release these energy bursts toward Earth and create space weather storms. What are space weather storms? Space weather begins with the sun. The sun gives off electromagnetic energy in many wavelengths, including visible light, radio waves, ultraviolet, high-energy X-rays, and more. The sun also emits a stream of radiation in the form of charged particles, plasma, that make up the solar wind. Occasional energy bursts resulting from huge explosions on the sun send plasma and radiation hurtling through our solar system, sometimes in the direction of Earth. Solar flares, coronal mass ejections, CMAs, and solar prominence events are examples of solar phenomena that can release these energy bursts toward Earth and create space weather storms. What are solar flares? A solar flare is an intense localized eruption of electromagnetic radiation in the sun's atmosphere. Flares occur in active regions and are often, but not always, accompanied by coronal mass ejections, solar particle events, and other solar phenomena. The occurrence of solar flares varies with the 11-year solar cycle. Solar flares are thought to occur when stored magnetic energy in the sun's atmosphere accelerates charged particles in the surrounding plasma. This results in the emission of electromagnetic radiation across the electromagnetic spectrum. Space weather impacts Earth. Earth's magnetic field helps to protect us from the effects of some solar storms. But how can space weather impact the Earth? Strong solar storms can cause fluctuations of electrical currents in space, directly impacting the power grid on Earth and energizing electrons and protons trapped in Earth's varying magnetic field. These disturbances can cause problems with radio communications, global navigation satellite systems, such as Global Positioning Systems, or GPS, power grids, and satellites. Imagine how we are dependent upon satellites, cell phones, weather prediction, TV, search and rescue, navigation, space travel, military surveillance, credit card and ATM transactions, and more. What if those satellites were damaged? As we become more dependent on technology, the need for space weather monitoring and forecasting becomes more important. As the solar wind flows past Earth, it mostly deflects around Earth's magnetosphere, the protective magnetic field that surrounds our fragile planet. Bursts of solar energy that travel toward Earth smash into the magnetosphere, sending particle radiation spiraling down along our planet's magnetic field lines. As these radiation particles collide with atoms in Earth's upper atmosphere, the resulting space weather storms sometimes produce spectacular light shows called auroras, the northern and southern lights. Space weather can also interfere with satellite electronics, radio communications, GPS signals, spacecraft orbits, and even electrical power grids on Earth. For satellites in orbit, the effects of space weather can be seen in the degradation of communications, performance, reliability, and overall lifetime. For example, the solar panels that convert sunlight to electrical power on most spacecraft will steadily generate less power throughout a mission, and this degradation must be taken into account in designing the satellite. In addition, increased radiation due to space weather may lead to increased health risks for astronauts, both today on board the International Space Station, in low orbit, and future on voyages to the Moon or Mars. On Earth, commercial airlines may also experience damage to aircraft electronics and increased radiation doses to crews at long-haul aircraft altitudes during large space weather events. Space weather effects on the ground can include damage and disruption to power distribution networks, increased pipeline corrosion, and degradation of radio communications. How solar flares impact Earth. Solar flares produce high-energy particles and radiation that are dangerous to live organisms. However, on the surface of the Earth, we are well protected from the effects of solar flares by the Earth's magnetic field and atmosphere. The most dangerous emissions from flares are energetic charged particles, primarily high-energy protons, and electromagnetic radiation, primarily X-rays. The X-rays from flares are stopped by our atmosphere, well above the Earth's surface. They do disturb the Earth's ionosphere, however, which in turn disturbs radio communications. Along with energetic ultraviolet radiation, they heat the Earth's outer atmosphere, causing it to expand. This increases the drag on Earth-orbiting satellites, reducing their lifetime in orbit. Also, both intense radio emissions from flares and changes in the atmosphere can degrade satellite communications. For example, the precision of Global Positioning System, GPS, measurements can be degraded. The most serious effects on human activity occur during major geomagnetic storms. It is now understood that the major geomagnetic storms are induced by coronal mass ejections, CMAs, which are frequently associated with flares. Like flares, CMEs are more frequent during the active phase of the Sun's approximately 11-year cycle. The exact relationship between flares and CMEs is still not well understood, as flares seem to trigger CMEs, but sometimes CMEs are observed without any flares. Solar flares can cause radio blackouts. Solar flares emit X-rays, among other types of electromagnetic energy. Increased X-ray emissions can scatter radio waves as a result of disruptions to the ionosphere, causing radio blackouts on Earth. Radio blackouts can last for a few minutes or even several hours and are the most common type of space weather impact experienced on Earth. There are on average 2,000 radio blackouts due to solar activity during each 11-year solar cycle. The energy from solar flares reaches Earth in about 8 minutes, which doesn't leave much time for advance notice. Because of this, scientists continually monitor the sun to make sure they can get alerts out as quickly as possible. In conclusion, the study of solar flares and space weather is crucial to our understanding of our planet's environment and the technology we rely on. Thanks to the cutting-edge instruments and telescopes of the Cherenkov Telescope Array, scientists are now able to monitor these phenomena with unprecedented detail and accuracy. By continuing to invest in this field, we can improve our ability to predict and prepare for space weather events, safeguarding our modern way of life and enabling us to explore the mysteries of the universe with greater clarity. Don't forget to subscribe to our channel, or you will miss out on our space-related videos.